In this lesson, you will learn more on classes and their relationships. So far, we looked into setting the values to an object after an object was instantiated. And we added methods to set and get those values. Setting values to the instance variable of an object defines its state. In this example, the instance variables which hold the state of an object are name, customer ID, address, and total. The actions or the work that an object can do are represented by methods. Since a method represents some action or work that an object can do, method should be a verb form. Notice we have followed the naming convention that was just presented, and all the variables have a noun form and the method has a verb form, getName, which is an action-oriented word. So instance variable define the state of an object and methods define the actions that the object can do. Let's now take the real-world example of a shopping cart which you are trying to represent in object-oriented programming language. Remember, in OOP, you try to represent the real-world objects in code. And how would you do that? So first declare a class called shopping cart. Of course, we want to mimic the real world as much as possible. So representing a shopping cart with a class which is also called shopping cart is the right way to do. And then you add the variables and methods to it. A reasonable first attempt may have an ID variable to represent the specific shopping cart, and you may also declare another variable to hold all the items that are put inside the shopping cart. After all, a shopping cart is used to carry items. Then the three methods that you may think of could be first, to add an item. Of course, that's the basic functionality of a shopping cart, right? You find an item, you should be able to add an item into your shopping cart. And the second is to remove an item if you change your mind. And lastly, to calculate the total price of all the items which are inside the shopping cart. The item itself may be represented this way. A variable to hold the item ID, another variable to hold the name, and one more to keep the total quantity of this item that is being purchased, and the price of a single item. Then there is one constructor to instantiate the item, and then there is one method to calculate the total price. Your main class, which uses all of these classes, may be represented like this. In this, you instantiate a shopping cart, and then you instantiate the three separate items that you want to purchase, and then finally find the total price to purchase all the items. So now we have three separate classes, and we are using one in another, and things are getting complicated. This is where representing the classes using Unified Modeling Language, also called UML, comes to our rescue. Using UML, you can represent the three classes with a class diagram. The first relation between my shop and the shopping cart is represented with an association. And the second relationship between the shopping cart and the item can be represented by a composition. In every class, the variables are declared first and then the methods. Private modifiers are shown with a negative symbol and public modifiers are shown with a positive symbol. Whenever one class uses another class, then it is an association. Composition is a special type of association in which one class cannot exist without the other class. So a shopping cart cannot be instantiated without first defining the item class. That's why the relationship between the shopping cart and the item is a composition. There are many other UML diagrams. I would encourage you to explore the sequence diagram also, and there are plenty of resources on the web.